From ancient tools to cutting-edge technologies, computers have not only transformed how we work and communicate, but also how we think about the world. This is the history of computers. Humanity's earliest attempts to make calculations easier. The Abacus, developed around 2500 BCE in Mesopotamia and China, was used to perform arithmetic operations. It's the earliest known device that mimicked computational thinking. It laid the groundwork for more complex innovations in computing. In 1617, Scottish mathematician John Napier introduced Napier's bones, a system of rods that simplified multiplication and division using logarithmic concepts. Just a few years later, in 1623, Wilhelm Schickard created the calculating clock, capable of basic arithmetic and considered the first mechanical calculator. In 1642, French inventor Blaise Pascal built the Pascaline, a gear-driven device capable of addition and subtraction. By the late 1600s, Gottfried Wilhelm Leibniz advanced this further with the stepped reckoner, which could multiply and divide, making it a true four-function mechanical calculator. In 1801, Joseph Marie Jacquard revolutionized textile manufacturing with the Jacquard Loom, which used punched cards to automate weaving patterns. This innovation influenced future programmable systems. In the 1820s, British mathematician Charles Babbage began developing the difference engine, a mechanical computer designed to perform polynomial calculations. By the 1830s, he proposed the analytical engine, featuring concepts like input, output, memory, a central processing unit, and conditional branching. In 1843, Ada Lovelace wrote the first algorithm intended to be executed by a machine, realizing the analytical engine could go beyond numbers, predicting modern computing. In 1890, Herman Hollerith developed an electromechanical tabulating machine for the U.S. Census. It used punched cards to encode data and dramatically reduced census processing time. His company would later evolve into IBM. In 1936, Alan Turing proposed the Universal Turing Machine, laying the theoretical foundation for general-purpose computers. In 1937, John Atanasoff and Clifford Berry began building the ABC, a Atanasoff-Berry computer, the first electronic digital computing device using binary logic and capacitors for memory. In 1943, the British Colossus was developed to break German crypto codes. It processed 5,000 characters per second and was used extensively at Bletchley Park during World War II. In 1944, Harvard Mark I was developed by Howard Aiken and Grace Hopper, an electromechanical computer capable of executing long computations. The 1945 Electronic Numerical Integrator and Computer, the ENIAC, was the first general-purpose fully electronic digital computer. It could perform thousands of calculations per second. In the same year, John von Neumann introduced the stored program concept, giving rise to the von Neumann architecture. This concept was first implemented in the EDVAC, Electronic Discrete Variable Automatic Computer, in 1949. The UNIVAC-1, delivered in 1951, was the first commercial computer used for business and government applications. In 1952, IBM released the IBM 701, their first commercial scientific computer. This marked IBM's entry into computing as a dominant force. In 1947, the invention of the transistor by John Bardeen, William Shockley, and Walter Brattain replaced bulky vacuum tubes and made computers smaller, faster, and more reliable. In 1954, Bell Labs developed the TRADIC, the first fully transistorized computer. In 1956, IBM unveiled the first hard disk drive in the IBM 305 RAMAC. It could store 5 megabytes of data using magnetic disks. In 1959, integrated circuits were independently invented by Jack Kilby and Robert Noyce, integrating multiple transistors on a single chip. This breakthrough allowed for mass production and the miniaturization of computing components. In 1960, COBOL, Common Business-Oriented Language, was developed for business applications, led by Grace Hopper. IBM's System/360 in 1964 introduced a family of compatible computers that shared architecture and could run the same programs, revolutionizing business computing. In 1968, Robert Dennard developed DRAM, Dynamic Random Access Memory, allowing for denser, cheaper memory storage. In 1971, Intel introduced the 4004, the world's first microprocessor, placing all CPU functions on a single chip. In 1973, Xerox PARC debuted the Alto, a pioneering system with a graphical user interface, mouse, and Ethernet. In 1975, the Altair 8800 ignited the home computer movement. It was programmable and caught the attention of a young Bill Gates. In 1976, Apple Computer released the Apple I, followed by the Apple II in 1977, which featured color graphics and expandability. IBM entered the personal computing space in 1981 with the IBM PC, which standardized hardware and software. Microsoft's MS-DOS became the most widely used operating system. In 1981, Sony introduced the 3.5-inch floppy disk, which became a global standard. In 1983, Apple launched the Lisa, the first commercial PC with a graphical user interface. In 1984, the Macintosh refined it with an accessible design. In 1985, Microsoft launched Windows 1.0, introducing the masses to a graphical interface. Same year, Dell released the Turbo PC, a customizable IBM-compatible system that defined early PC sales. In 1989, Tim Berners-Lee proposed the World Wide Web, a system of interlinked documents using HTTP and HTML. In 1991, Linus Torvalds released the Linux kernel, sparking the open-source movement. In 1993, the Mosaic web browser made the Internet accessible to the public, paving the way for Netscape, Internet Explorer, and the dot-com boom. Microsoft's release of Windows 95 brought the Start menu, taskbar, and plug-and-play support to millions of users. The late 1990s saw the explosive growth of the Internet, e-commerce, and digital media. Companies like Google, Amazon, and eBay emerged during this time. In 2001, Apple launched Mac OS X, blending Unix stability with modern design. In 2007, the iPhone changed everything, ushering in the smartphone era and the mobile app ecosystem. Google introduced Android and the Chrome browser in 2008, offering open and fast web access. Cloud computing platforms like Amazon Web Services, Microsoft Azure, and Google Cloud enabled scalable storage and computation. Smart devices, from watches and speakers to thermostats and fridges, integrated with AI assistants like Alexa, Google Assistant, and Siri. In 2016, DeepMind's AlphaGo defeated world champion Lee Sedol in the ancient game of Go, demonstrating advanced machine learning. In recent years, quantum computing has accelerated. IBM and Google have developed processors capable of performing calculations impossible for classical machines. Brain-computer interfaces like Elon Musk's Neuralink are under development, aiming to bridge biological and digital intelligence. The 2020s have seen explosive growth in generative AI in medicine and finance, edge computing, 5G, augmented reality, and the metaverse. These advancements are shaping the next frontier in computing. What do you think computers will look like in the future?